Hello, welcome to my channel. Now we will see physics for NEET and JEE. The topic is electric field. We are going to take one question which was asked in one of the earlier exams. So this is going to be one question solved. So solved paper. Okay. Now we can see this is a question. An infinitely long cylinder of radius r has a uniform charge density rho. It has a spherical cavity of radius r by 2 with its center on the axis of the cylinder as shown in the figure. Figure will be coming now. The magnitude of electric field at a point P, which is at a distance 2r from the axis of the cylinder, is given by the expression 23 rho r divided by 16 k epsilon naught. The value of k is, you are supposed to find the value of k, which is shown here. This is IIT JEE 2012 question. We see how to solve this. Right? This is the diagram given for this question. This is a cylinder. You see an infinitely long. So to indicate that it is infinitely long, this kind of broken line is shown here. Okay. This is a cylinder, uniform charge density rho, and it has a spherical cavity here. That means the spherical portion is removed. A spherical portion has been cut out and there is a cavity here. Okay, this is a cavity. The radius of the cavity is r by 2 shown here. Okay, with its center on the axis of the cylinder shown in the figure. The magnitude of electric field at point P, which is at a distance 2r from the axis of the cylinder. Point P is here at a distance 2r from the axis of the cylinder, is given by the expression 23 rho r divided by 16 k epsilon naught. The value of k is, right? So how to find the value of k? First you find the expression for the electric field due to this kind of a shape and compare it with the given expression, and whatever is there in place of k, you just identify it, then that will be the value of k. Got it? So for this you should know some basic formulas. What are they? Electric field due to an infinite cylinder of charge distributed uniformly throughout its volume. Electric field due to an infinite cylinder of charge. Okay. So for that, what is the formula? This is the infinite cylinder, say radius r, point P at a distance small r. Then the electric field is given by rho r squared by 2 epsilon naught r. This proof has been given in one of my earlier videos. I will give the link below in the description box. You may please visit and find it out. But for now, we will assume the formula. E is equal to rho r squared by 2 epsilon naught r. Here you should be knowing epsilon naught is permittivity of free space with a value 8.85 10 to the power of minus 12 farad per meter. This one, this epsilon naught here. Of course, you may not be using it, but I am just telling you so that you will know what is epsilon naught and what its value is. And this small r is this distance of the point P. This is for a complete cylinder. Okay, complete cylinder of charge for a point outside. Then also you should use the formula for the electric field due to a uniform sphere of charge, the charge being distributed throughout its volume, and the formula is rho rs cube, r subscript s, r sub s cube, which rs here indicates radius of the sphere. I have not used r because r has been used for the cylinder here, so I just put rs to indicate radius of the sphere. Rs cube divide by 3 epsilon naught r squared. This is the formula. These formulas you will be using in solving the given question. See, this is the complete cylinder. That means this has got the sphere also here. So what happens from this cylinder? I have given it in the next picture. A cylinder, a spherical portion has been removed. So complete cylinder with the sphere inside. So you will take it as a complete cylinder. But from this a spherical portion is removed means there will be a cavity. He has not given in the question spherical portion is removed, but he has given in the question as if there is a spherical cavity. You see here, this is a sphere from which the spherical portion is removed, imagine. So this is the spherical portion. Now your aim is to find the electric field due to this cylinder of charge with a spherical cavity. So how do you proceed? In fact, you see, as the diagrams indicate, the electric field due to this array will be equal to electric field due to this plus electric field due to this. Imagine this is there, then you will get this. So for points outside, we are going to discuss. Do you understand that? Therefore, this is equal to this plus this. In terms of the electric field, point is considered outside here, right? So you write the respective formula here. You see, this is E. E is the cylinder with no cavity, and that should be equal to E1 for this electric field with the cavity. Our aim is to find E1. This is a spherical portion, right? So this is equal to E1. You should E1 is equal to E minus E2. Are you able to follow? Because E1 is here, E is here, E2 is. What is E? Electric field due to the full cylinder. What is E2? Electric field due to the spherical portion. Right? We will proceed further, and E is this rho r squared by 2 epsilon naught r. What is E here? Cylinder. I already gave this formula in the beginning. Then what is E2? Rho rs cube by 3 epsilon naught r squared. You will have to substitute the proper values for small r and rs. You will get the final expression for the electric field. So how to proceed to that? You see here, E1 rho r squared by 2 epsilon naught r minus rho rs cube by 3 epsilon naught r squared, where rs is the radius of the spherical portion, which is given in the question as r by 2. So for rs, you will have to substitute r by 2. For small r, you will have to substitute 2 capital R. That was already given in the problem and also in the diagram. So now E1 is rho r squared by 2 epsilon naught r minus rho r cube by 24 epsilon naught r squared, because for rs, r by 2 has been substituted. So rs is r by 2, rs cube, r cube by 8. That 8 multiplied by this 3 will give you 24. This epsilon naught r squared as it is. But small r, you will have to substitute as 2 capital R. Therefore, E1 is rho r squared by 2 epsilon naught, rho r squared by 2 epsilon naught. For the small r, put 2 times this capital R. This minus as it is, then rho r cube again as it is, 24 epsilon naught as it is. For small r, you put 2r, but you have to square it. Understood that? So rho r by 4 epsilon naught. Here you see r squared and r, one r will go. So rho r. This 2 and this 2 multiply 4 epsilon naught. That r has been cancelled. Okay. So 4 epsilon naught here. One r has been cancelled with the r square in the numerator. So rho r by 4 epsilon naught. Then coming to this term, this minus of course has been written there. Then rho r cube 24 epsilon naught 2r the whole square. In this r square will be there, r cube is there. So r square and r cube, you can cancel r square with this r cube in the numerator. So there remains one r in the numerator. This row as it is. Then when you square it, you will get 4. This 4 into 24, 96. Epsilon naught as it is. This on simplification, taking LCM and all, you will get 23 by 96 epsilon naught rho r. This is the electric field due to the uniform cylinder of charge in which the cavity is present. The cavity has got a radius capital R by 2. This is the electric field. But you see the given expression 23 rho r by 16 k epsilon naught, but we are getting 23 96 epsilon naught. Rho r is here, of course. Okay. So comparing these two expressions, you will get k is equal to 6, because when you put k as 6, you will get 96 in the denominator. In fact, that is the correct expression. Okay. Therefore, the value of k is 6. This will be the answer. The 6 will be the answer. Have you understood everything here? Okay. Now, thank you. Please like and subscribe.